Welcome back everyone to part 2 of our 5-part video series about the Trinity demonstrator at the Fraunhofer IWU. This video will focus on the demonstrator. You will learn about its development, its benefits, and its functions. This video is structured as follows. It starts with an explanation about the task of the demonstrator. The benefits of the demonstrator and its contribution to agile manufacturing follow. Then, I present you its design evolution and will go more into detail about its technical specifications. The connection between the modules and the use case will be explained afterwards. The video comes to an end with an overview of the remaining videos. Let's start with the demonstrator's tasks. The initial situation of the workstation is that two assembly workers assemble printed circuit boards or PCBs manually. They mount electronic components such as resistors and capacitors onto the PCBs. Before the PCBs go to soldering, a manual quality check is performed. Since the mounted parts are through-hole technology components, they have long and thin lead wires that have to fit into the holes of the PCB precisely. This is the reason why through-hole technology components are mostly assembled manually. A full automation solution for such a process would require an immense investment. The process is repetitive and requires high concentration. Another challenge for this particular case is that order volumes vary. That means there are times when two workers have too much or too little work. Therefore, a low-cost automation solution was desired by the workstation owner. In the new workstation, one workplace should remain manual and the assembly of the components should be split up between one worker and an industrial robot. After knowing about the demonstrator's tasks, I will give you a better understanding about its benefits and its contribution to agile manufacturing. The partly automated workstation helps with sudden changes in demand. Times with lower demand are compensated better, since in this case only one person is confronted with a lesser amount of work instead of two. And during a period with an increased amount of work, the shorter process times of the robotized process facilitate meeting the needed output. Furthermore, repetitive tasks are reduced. An automated quality control does increase the quality. The automated process simplifies the digitization process, since the process now can be included in the company's existing software solution for production planning. Here you can see the design evolution of our demonstrator. It underwent several iterative updates during its development process. I will mention the most notable changes. The reorientation fixture next to the robot was overhauled. Now several components can be put down at the same time and the mechanism changes their position. The component containers are now put on rails to improve the material flow. In the final iteration, the possibility to discard empty container boxes was added. The robot can drop empty boxes into an opening beneath the conveyor. The functions of the demonstrator will be explained in the following. This figure of our demonstrator gives you an overview of its main functionalities. The safety casing has two openings, one in the front and one in the back. This allows the worker to reach into the workstation. The worker is still protected because light barriers will force the robot to stop any movement. We use an industrial robot with a suction cup gripper. A high precision model is needed for this application. The workpiece carriers are moved over a roll belt conveyor with a pneumatic function to correctly position the workpiece carrier. The material containers contain electronic components in various delivery states. The backflow of empty containers is performed by the robot as soon as a container is empty. An intermediate storage is needed. It acts as a reorientation station. Not every component can be picked up in its assembly position, which is why they need to be placed into the storage in order to be picked up again in the correct assembly position. In order to detect the components and to perform the quality control, we use the vision system. It is mounted onto the robot next to the suction gripper. Since you are now familiar with the demonstrator's main functionalities, I will close the bridge between the demonstrator and the modules I mentioned in the last video. In order to develop the demonstrator, several methods were applied to support the development process. These methods reflect the development process and were described and worked out in the form of training modules so that you can use them in order to plan your own workstation. The modules are the MTM analysis module, the handling and assembly module, and the vision system and quality assurance module. MTM analysis is a specific type of analysis that identifies process times of manual assembly steps. This analysis builds the foundation of the automation process. In the handling and assembly module, we developed a methodology in form of a flowchart. It supports the process of planning an automated workstation. In the vision system module, we included the most important aspects that have to be considered when implementing a vision system for quality control. The three modules are going to be the content of the following videos. The content of this video was the overview of the demonstrator, with its goals, benefits, applications, and technical components. The three upcoming videos will deal with the modules in detail. The first one will be about the MTM analysis. This wraps up our second video. See you in the next one.